Sir, so suppose due to any of the reason, if net is disconnected for a while, so
Yeah,
I think I will further reconnect it in a
no problem.
couple of 1 minute.
No
No issue,
problem.
no, sir.
No problem. No problem. No
Because
problem. No
because
problem.
there is a backup issue at my residence right now.
No issue. No issue. No
I'm
problem.
expecting. No, okay, fine.
No problem. No problem. You are in right now in Delhi.
Faridabad, sir. In the
Okay.
NCR region, sir.
Okay. Faridabad. Okay. Very good. Very good. Thank you. Thank you very much. Thank you.
So, sir, shall we start? I think it's 11. Or should I
Within
wait?
two. Yeah. Within 2 minutes.
Okay, fine, sir.
Thank you. Thank you. Very good morning to all. As per our Saturday's series, today we have one another very important topic related with measuring and controlling of parameters of electrical vehicle system. As we are all aware, this is a new concept and we are expecting that within few years in India we will be having only the electrical vehicles. These fossil fuels and other fuels, maybe the green energy may continue, otherwise these fossil fuels will be removed. We have with us Dr. Abhinav Saxena, who is a BTech in electrical engineering and MTech from IIT Roorkee in 2013. He is PhD in electrical energy for engineering from Jamia Millia Islamia. His research area include renewable energy based power electronics and derived electrical machines, power system, artificial intelligence techniques, machine learning, design of non-linear controller, smart grid, electric vehicle controlling, including battery charging, congestion management, DG, energy management, artificial intelligence technique, analysis of biological equipment, machine learning, sustainable and green solution. He is having a teaching and research experience of more than 12 years. He has published more than 100 research papers in various SCI, Scopes, Web of Science journals, book chapters, and in various reputed conferences like IEEE and Springer, etc. He has also published 18 patents and 4 patents granted. He has completed the research grant of rupees 5 lakh under the scheme of AKTU Vishweshwara Research Promotion Scheme. Recently, he has also received the Best Teacher Award 2021 from Dr. APJ Abdul Kalam Technical University, Lucknow, and Excellent Teacher Award in 2022 from AI Falah Humanity Council. He has supervised one PhD student and co-supervising 3 PhD students across the various universities of the nation. He has delivered many lectures as a keynote speaker in various conferences and FDP. He is also a senior member of IEEE. Currently, at present, he is working as assistant professor in electrical department of electrical engineering and at JC Bose University of Science and Technology, YMCA, Faridabad. It is in Haryana. Thank you very much, sir, for accepting our request and delivering this talk on this very important topic. We have with us our Honorable Shri B.N. Dikshit Sahab, who is known in the legal metrology fraternity all over the world. He has, due to his patience and working very hard in the legal metrology, in developing the legal metrology system in our country. I would like to request our Honorable Shri B.N. Dikshit, Director, sir. Sir, would you like to speak 2 words, please? Dikshit, sir. Sir, we are not able to hear you. Shri B.N. Dixit, sir. I think, sir, your mic is off. श्री सर दीक्षित सर आपका माइक बंद है.
अब
Yes sir, now it is okay. Please, over to you sir, please.
हाँ हाँ, वेरी गुड मॉर्निंग श्री आशुतोष जी, डायरेक्टर लीगल मेट्रोलॉजी गवर्नमेंट ऑफ इंडिया. सक्सेना साहब, टुडे द चीफ गेस्ट ऑफ द प्रोग्राम.
अच्छा सर.
Topic is also very excellent. The electrical vehicles and their measurement systems, and also it will reduce the energy, particularly because the is importing lot of the crude oils, and that crude oil has become a country economy. And if the more electrical vehicles will come in the market, and people will buy, this will be boon for the country, and lot of the funds and economy will be diverted towards the development country in very different fields. The poverty and upliftment of the people, hospital, patients, education, and the modernization.
I think sir your voice is breaking. We
Yes,
are not
yes, yes.
able to hear you.
So I think this electrical vehicle will be effective state, and a lot of the crude oil that being imported from the other countries will be stopped. Our lot of the money will but from the legal point of view, one point I think that is very important. If the electrical vehicles are also coming, battery systems is being very important, like the fuel measurement, all those things. So that some measuring system that should be bring out in the rule frame of the legal methodology. That responsibility of the Department of Consumer and of the director legal methodology. He should do some of the things. Apart that uh, this will work as a renewable energy also, and it will play very important role. With these very words, I think that um, I give again request Director Legal Methodology Sri Ashutosh Agrawal ji to speak something and invite our chief guest Dr. Saxena for this very program. Thank you
Thank you
everybody.
sir. Thank you very
Thank you,
much
sir.
for your
Thank
kind and motivating words. Thanks a lot. Thank you sir. Thank you. Now I'd like to request Professor Mr. Dr. Abhinav Saxena to kindly take over. Over to you sir, please.
Okay. Thank you so much, sir. First of all, I am highly thankful to Dr. Ashutosh Agarwal, Director Legal Metrology, for giving me the opportunity to speak such a podium. I am also thankful to Professor B.N. Dixit, sir, for giving a valuable insight about the EV system here. So today, my topic for this talk is, sir, am I audible to properly?
Yes sir, very well, very well. Please
Oh,
continue.
thank you, thank you.
Thank you.
So my topic for this talk is the measuring and controlling of parameters of EV system. It is an electric vehicle system. As of now, we can see the popularity and the implementation of the electric vehicle system has been increasing day by day, because it has so much of benefits. Like the first, it can be work as a source. Source means power delivered. That they, and the main thing is the main contribution. It is can also work as a load here. So we'll discuss the EV system in both the cases here. And in order to uh, operate the EV in both mode, it is required to check each and every parameters, and that measuring of the various parameters can be assessed by doing by providing the suitable amount of controlling. It means we have to provide a controller for this tuning of the various power tonic converter connected between the system here. So that is why the measuring and controlling of the parameters of the EV system here. So we begin with just a second, sir. So can you see my this next slide?
Yes, sir. Yes, sir.
Okay, fine, fine. So we begin with talk with the various challenges with the EV electric vehicle. Basically, uh, because if before we talk about the advantages of EV here, so let's see what are the various challenges on which the research is going on right now. The first and the most typical challenge is purchasing cost. If we talk about the cost of an EV system, it means it is directly associated with the cost of the EV battery. So as of now, we see most of the EV are batteries are lithium-ion batteries here. So they are very highly costly. So it is being seen that it is not being reachable to each and every person here. So most of the research is going on to decrease the cost of the EV battery. So as of now, you can see the country like China and others, especially China, if you talk about, they have what they did, they have replaced the lithium-ion battery with a sodium-ion battery consider, in order to reduce the cost of the battery here, keeping in the mind without any compromising the performance parameters. Okay, but still that is of a highly concept here. But the countries like India and nearby neighboring countries, they are still working on lithium-ion battery. But what is the advantage of lithium-ion batteries? If you see, like it provides us very highly diversified and more amount of efficiency here. So that is why it is highly preferred and easily available. Okay. So if you talk about the sodium-ion battery, yes, sodium-ion battery is not easily available because it is very difficult to keep the sodium on a tree here. So that is why lithium-ion battery is mostly preferred, and that is one of the its cost is one of the biggest concern here. Next is the range anxiety. It is not a kind of anxiety. Anxiety means is availability here. So as of now, if you see the more companies like Toyota, even most of the companies are provided a lot of variety on EV here. But if you see, they have only single version of EV here. So still we have a very lack of this this range of this EV system here. Another one is again like a limited selection. So still, as of now, if you see daily, if you hear each and every month, each company is producing its own version of EV here. But still, although it is quite limited, okay, because of this highly costly. Another challenge is that if we got any difficulty, if we got any issue with the EV, so it is very difficult to find a proper engineer because normal, if you see our like vehicle which is based on petrol and diesel, these can be easily solved. Any problem associated with this EV, petrol and this diesel locomotives can be easily solved out by our local technician. But for EV based system, it is very difficult to find a technician. For that, you need to go a proper workshop where they will assist you by providing a certain technician. Another challenge is the charging infrastructure. Sir. As of now, government is also promoting to install various charging stations across the various petrol stations. In fact, most of the high-rise society, they're also having the facility of this charging infrastructure. Also, if you go to very any hotels like, so they are also providing the charging infrastructure, but they are quite limited. Okay, so this is also one of the biggest challenge with the EV system here. Another one is charging speed. Although the charging infrastructure is given to us, but the issue is that sometimes it takes a lot of time, like 1 hour, 1 hour 30 minutes, depend upon this battery capacity or charging speed here. So it takes a lot of time here. So mostly research is going on how we can minimize the charging speed. It means how the EV can be charged, how it can be charged with a minimum spare of time here. Next challenge is grid capacity. Although if we see most of the electric vehicles are quietly directly connected to the EV with a systems of this power transfer converter here. But if the grid capacity is not suitable, it cannot be provided for charging those EV system here. So that is one of the biggest concern. Last one is again the charging price infrastructure. Charging price structure. The charging price structure is like it includes the cost of battery and other components here. So that is also one of the concern here. So our most of the researchers are working on this part, especially is cost part here. Okay. So these were the challenges. Now, what are the future benefits? What are the benefits of the electric vehicle here? So you can see like it is have a lot of advantages because the cost is so much less compared to fuel and especially with respect to the gasoline vehicle here. Our EV will typically cost around 50 to 70%. Fuel is lesser, and it requires also very lesser maintenance as compared to the gasoline vehicle. Normally, if we see when there's a if you set up and charging infrastructure at your home, so you have to spend around $1 per gallon for this gasoline vehicle here. Okay. Although if you see for the electric vehicle also provides because it has so much of a gasoline vehicle like CNG we talk about. It has a lot of movable parts here. But if you see the EV has very lesser amount of moving parts here. So like gasoline, it doesn't require to change the oil frequently. So that is why routine and ongoing maintenance are cost very lower in the case of EV in comparison to gasoline. Next one is it is as you also read, the most popularity of EVs is highly eco-friendly. Eco-friendly means like it is high provides like it is highly sustainable solutions here. It is quietly easily reachable to each and everyone here. Next one is inevitable. And the last and the most beneficial part of this one is it doesn't provide any type of carbon emission which maintains sustainability. Because if you see our this four-stroke and two-stroke vehicles here, which are purely based on this petrol and diesel, they generates a huge amount of smoke. At the end, which is in the form of carbon here. So this carbon emission automatically contribute in the pollution level here, and at the end, the sustainability in the environment will be affected here. So such type of issues can be easily overcome with the help of the electric vehicle here because it doesn't allow any carbon emissions here, and it also maintains sustainability. Okay, so these are the few benefits of this electric vehicle system here. Another benefits, if we talk about like if you compare, as we discussed, like electric vehicle is quite much suitable as compared to any gasoline vehicle because it also takes a very fewer life cycle emissions here. It is a very negligible one here. Even after the accounting of emission or the production of the vehicle here, like if you see, let's compare the annual vehicle emissions by the fuel. Emission means if we talk more totally about not only a carbon emission, especially we can also consider like nitrous oxide and this PM level here. So if you just compare this the gasoline vehicle carbon emissions and the EV here. If you see the first column here, if you see in the first column, the gasoline vehicle provides around 9,200 lbs carbon dioxides. Similarly, for the nitrous oxide, 20 lbps, and the PM level is around 1.4 lbps here. Same thing if once this gasoline vehicle has been replaced with EV, the EV has two aspects. It is like an off-grid or on-grid. Like if it is being directly connected with the grid, what happens? Obvious, it provides a very handsome results here. That is, it's the carbon emission part will be automatically reduced. Here you can see the carbon emission has been reduced from 9200 to 3000 here. And from this nitrous oxide level, it has been reduced from 20 lbps to 5 lbps. Same for PM level here. The another advantage of this EV system is in the second level, if you have seen, the EV has been connected to the grid. There is a one more possible option that if EV is charged with the help of renewable energy, renewable we talk about specifically the solar one. So what happens, because the grid connected EV also offers some amount of this carbon dioxide, nitrous oxide, because the at the end the grid also receiving the power from this conventional sources here. So automatically this some amount of some amount of this emission will be present. But if the EV got a charging from the solar energy, automatically all this emission will be totally absent. You can see like in third column there will be no carbon emission, no nitrous oxide, no approximately very zero point 0.3 PM level here. So this is how the EV charge setup with renewable energy system is preferred. But again, the issue is this is a very tedious and a very highly costing part. Okay, so again, it has to be planned to minimize the cost of this overall system because it is the most highly sustainable solution, highly most sustainable system. The charging of EV with the EV because it doesn't cause any air pollutants. So as we discussed, like the few challenges like is charging infrastructures, as we discussed, grid capacity and peak demands, interquality and standard, cost of infrastructures, urban planning, charging management, public awareness, and all. Now we see what are the possible type of EV here. The first EV, there are basically four type of EV system: battery electric vehicle, hybrid electric vehicle, fuel cell electric vehicle, and plug-in electric vehicle. So we'll see here, all we will see all these four type of EV here one by one. The first one is called to be a battery electric vehicle here. So as here, battery electric vehicle means obviously you can see like the electric vehicle, this power given to this EV, especially the motor part. So what happens? It is the power for the electric vehicle is converted from the DC battery to the AC. So if you see the infrastructure here, in this one the various battery packs are is connected and cascaded with the electric motor here. So what happens as the accelerator is allowed to press, the signal is being given back to the controller here. The controller has an option to adjust the speed of the vehicle by changing the frequency of its powers from the inverter to motor. Because normally battery is having the DC, and if we and it is occupied with this electric motor here, which is normally we consider AC motor, so that can allow the variable frequency operations here. So further, this motor can connect and lead to the turning of the wheels through a cock. Now, what happens if any brake has been pressed? So this electric vehicle can be deactivated because this is the very most advantageous feature of this EV here. Normally, if we compare the EV with our conventional vehicle, what happens? Whenever we apply the brakes in our this four-stroke vehicle, especially of petrol and diesel here, that is a totally mechanical braking here. It is totally wasted. But in this case, if you consider in the EV, the applied braking in the EV is totally a electrical braking. Okay, so that electrical braking has advantage to convert that the dissipated energy into a useful energy, which can be further utilized as an input for the EV for this charging. It means that motor can also be converted to a generator here. So this is how the efficiency of this EV system can be improved. Another type of EV electric vehicle is called hybrid electric vehicle. So in the previous one, we have seen we have a series type of connection, but in this one, we have two type of more connections like series hybrid and parallel hybrid. So it can this hybrid electric vehicle. That is what is called hybrid one because it has both operations, series and parallel here. Now it is accommodating both engine as well as motor here. Now what happens there? What are the possibilities? The engine can get some power. Now there are two options for this energizing the engine. Either the engine can get the energy from this available fuel here. If it is absent, then what happens? This motor gets electricity from the various battery to a converter here. Now once this motor is getting from by converting from DC to AC, now this electric motor will assist to this operate this engine here. Now this because both is engine and engine shaft and motor shaft are common here. So this transmission is rotating simultaneously to both engine and motor here. Now this then driving the wheels. Okay. So Another type of hybrid electric vehicle is called the plug-in. It's the most popular one. Plug-in hybrid electric vehicle is mostly basically, if we see like a series type of connections here, it also accommodating both engine as well as motor. Normally, what happens? It is in our choice whether we in the previous one it is like mandated to operate with a fuel, but in this one it is our choice to either we can allow the engine to operate either as a fuel, that is our conventional fuel like petrol or something like that, and it also we can recharge it from a given battery pack, which is like externally here. So it is an option that either we can would like to run it from the fuel or not. Another type of EV is called fuel cell electric vehicle here. So if you see, it's totally a zero emission vehicle here because it totally employ the fuel cell technology. It generates electricity to run the vehicle here. Now what happens? The chemical energy of the fuel is directly converted into electrical energy. So if you see like the various component of this fuel cell electric vehicle, so it is now you totally see previously, we were this motor was operated with the support of this battery, and now we have taken then additional hydrogen tank here. What happens? This hydrogen tank is basically another type of fuel cell that has been directly given to the PC for this operation of this electric motor. Suppose if any or due to any of the reason, the fuel cell is not allowed to give the signal to PCU. Now, in that case, the battery will work as a backup operation to operate the PC so that electric motor can be worked out easily here. So, so this concept is being used by the various company like Toyota. You can see like Toyota Mirai, Riva Simpal, Honda Clarity, and all. So most of this is mostly being used as of now here. Now we can see like what are the various charging aspect of the EV. So there are three levels: AC level 1, AC level 2, and DC fast. The third one is being mostly used. If I compare these three, we begin with this AC level 1. So AC level 1 has a voltage of 120 volt, and it is having a current huge current capacity of like 12 to 16 ampere, and it can allow the load only up to 5.1 sorry 1.4 to 1.9 kilowatt. And this charging time capacity it can charge electric vehicle for this so that it can run up to only for 3 to 5 miles only for per hour. So just because it's very limited, very lesser this coverage capability, this AC level one is very rarely preferred. In order to have some better option, the AC level 2 is preferred. Now in this one, once two level option has been taken, automatically the voltage level has been increased from 122 to 208, and current level has been increased from 15 to 18 ampere. Typically, we take around 32 amperes for level 2, and our this charging load it was like from 1.9 kilowatt. It has now increased to up to 19 kilowatt. This is a very huge gain here. The most advantageous part is previously you can see the AC level 1 allow the EV to run for 3 to 5 miles per hour. Now, which has been increased with AC level 2, which has been like 10 to 20 miles of range per hour. Still, this is very less. This range is very less here. Okay, so in order to have some better option, DC is being commonly used. Voltage level is same, but the current capacity has been increased because we have to increase the charging speed. So automatically we require a high current. So this current has increased to 60 ampere. And the charging load, you can see previously it was like 19.2 kilowatt. Now it has been increased to 90 kilowatt here. Okay. So what happens is because of this higher charging load capacity, this charging time has been so much of it got us so much drastic change in charging time. It has been reduced a lot. Previously, it was like 10 to 20 miles per hour. Now, this battery can get fully charged up to 20, within 20 to 35 minutes, and it can run for this complete charging capacity of about 250 kilometers, 250 kilometers approx. Now, if we discuss in detail about this level 1 and level 2 charging, so all the electric vehicle can regulate the outset for level 1 charging. This is a typical configuration of this level 1 here, especially for level 2, like if you can see like it has some amount of higher voltages. So Tesla machines mostly uses a level 2 charger here. Okay. So what happens? So one Tesla can use a one Tesla plug here. Another, if we see the evaluation of DC fast charging, So many DC fast charging have the stations like CCS, commutative plugs. Okay, all the electric vehicles can use these plugs here. Because Tesla use an adapter for the commutative plug here. Again, one Tesla can use the one Tesla plug. Okay, so now this was this simple literature review part. Now, in my research, what happens? I'm considering these four objectives in my EV system. First, as I discussed in the earlier slides, that is the charging of the EV with a solar photovoltaic cell. I did both. The charging of EV with renewable energy and without renewable energy. So I will see here one by one. Second one is I told you that the battery charging cost assessment is a very one of the biggest concern. I also did to how I can minimize the battery size. But if I sorry, if I reduce the battery size, automatically the battery cost can be reduced. So for that, it has been done by formulating an objective function that has been controlled with the genetic algorithms and other AI techniques, so that the battery size, battery arrangement, and the battery cost can be minimized. Another, I told you that if you are considering battery, so it is also required to consider is a maintenance aspect. So maintenance aspect of the battery is relies in terms of risk analysis, which is ensuring and enhancing the life expectancy of the battery. So higher the risk analysis, it means that the battery can sustain for a such an amount of during the day, for such amount of a longer duration. And that risk analysis has been done with the help of fuzzy genetic algorithm. Another one is the regenerative braking action of EV system. As I told you that it means that EV has two modes. As you know that sometimes it is called E2V and V2V. Sorry, V2G and G2V. That vehicle to grid and grid to vehicle. So this is like a vehicle to grid system here because it is a regenerative mode. It means it is providing a power that is back to the grid here. So this is like a typical charging infrastructure of the EV system here. So as I told you that this is a grid here. Normally, it's a conventional one that is a single charging point has been provided in the grid, and this charging point is getting here. What happens? The battery has been assembled. Various batteries are assembled in the car, this matrix form here, and as battery has been provided the various available vendors. This was a very conventional approach. Okay. Now, once this got a sufficient amount of batteries, the grid has a potential to get charged EV. So once it is if any nearby EVs comes out, that then this EV can get charged from this grid here. So this is called grid to EV for charging here. Now another the beauty, as I told you, of the EV is that if it is in operational mode, what happens? It can deliver back the power to the grid. It's called EV to grid for the and that action is called regenerative power actions. So as I told you, this is called there are two mode of operation: grid to vehicle and vehicle to grid. So I did both of them. So this is my research here. Now in this one, as I told you that I have considered this solar photovoltaic as a renewable energy source for the charging of this EV here. So in because normally what happens is the this output of the solar photovoltaic cell is not sufficient to so that it can directly charge this EV here. So in order to provide a sufficient amount of voltage, we need to connect a power transfer converter between this renewable energy and solar photovoltaic cell and EV. So automatically what happens? The output of the this battery is connected. Then what initially the output of the solar photovoltaic cell is get stored in the battery, and that battery is connected further in series with boost converter because that boost converter is directly increase the magnitude of battery here. Okay, because battery voltage, because this amount of voltage is not ambient, is not sufficient to get charge the EV. So it is required to increase that voltage. That is why we have increased this voltage here. But again, the question is, since it is a part on its control converter, it has to be get it has to get a certain amount of gate pulses. That is called switching process. So how it has been done in the solar photovoltaic cell initially, because we know that in the solar photovoltaic cell, the radiations are continuously varying from morning to evening. Because of that, it is very difficult to get track the maximum power here. Because we know that the efficiency of solar is very less. It is around 15 to 80% here. Well, because this very lesser efficiency of 15 to 18%, in that we want to track the maximum power. So that tracking of the maximum power is very difficult. So here we use a certain algorithm like there are so many algorithms. The most popular one is part-time and observe. So I've used a part-time and observe algorithm here for tracking this maximum power. Okay. So with the help of part-time and observe, the maximum power has been detected. And in addition to this, it has also advantages to provide a gate pulses for this boost converter. This is how boost converter can be controlled, and it increases the battery voltages. After that, because we need to set up a certain variable voltage, so we have also connected the DC-DC converter here after in cascading with the boost converter. Again, it is also a DC-DC DC-DC it is converter. Basically, it is typically a buck boost converter here. So again, it is a part on is control converter. So we need to provide a certain switching pulses here. That switching pulses again is again assessed with the help of this optimization technique that is called heuristic Lyapunov fuzzy logic controller. With the help of this heuristic Lyapunov fuzzy logic controller, this switching of the DC-DC converter can be done. So this is the one way that this further the output of the DC converter is get directly to get charge the EV. So this is the way to charge the EV from this solar photovoltaic system. Suppose due to any of the reason, like in the night hours or this rainy season, solar is unable to work, or so it is not providing sufficient amount of voltage. So in that case, we can directly this EV can directly get a power from the available BESS system. That is called battery energy storage system. Again, DC-DC converter is being connected after BESS. Again, this DC-DC converter is also getting switching pulses from this heuristic Lyapunov fuzzy logic controller here. So this solar photovoltaic is sorry, this EV is getting power from both the sources. One is from solar photovoltaic cell, another is from battery energy storage system. So it is observed. So it is preferred that during peak hours, especially in the afternoon time from 11 to 4, it is preferred to charge EV from the solar photovoltaic cell, and during non-peak hours, it is preferred to use BESS to charge the EV. So as we have seen, there are DC-DC converter here. We use in this solar photovoltaic cell. So there are certain configurations of this DC-DC converter. As here you can see my study. So there are four aspects like how it can be worked. There are four mode of operations. So if you see, like in this first one, if the J1 switch is open, okay, and J2 is closed, then the mode one is one. Okay. And for the if so in this one, accordingly, this inductor is getting charged, and which the charge inductor is delivering the power to the battery. In the next one, if we see both as J1 and J2 are closed up. So once it is closed up, what will happen? You can see like uh, the power of this solar photovoltaic cell is stored in this capacitor, and further it is back to this battery with the help of this with the support of this diodes and this fault tolerance switches here. After that, in the mode 3, if you see, J1 is open. So J1 is closed and J2 is open. It means there is no battery. But what is the suitability that inductor can suitability charge? Well, this stored inductor can also deliver. It can also work as a sources to deliver the power to the battery. Another one is like the some like in this one, this is a diode DPV. It is being totally forward bias here. Okay. So accordingly, with this J1 open, J1 close and J2 open. So these are four mode of operations of this DC-DC converter are possible. So this was a DC-DC converter that was, as here you can see, there are two type of DC-DC converter. One DC-DC converter is connected between solar photovoltaics and this EV. Another one is connected with the BESS. So this was with the solar photovoltaic cell, and another DC-DC converter is with BESS. So here you can see like the DC-DC converter is getting the pulses with the help of PWM generator here. So as here you can see like there are three stages here. The stage one, again this maximum voltage has been received and it is being converted, it has been received, it is being compared with this reference value. After the output of this one is go to PI controller, and this is providing a one type of switching pulses, because here we have six, here we are using six switches there. So one switching pulses we are getting from this one here. Another two is are getting from the stage two, that is again is being compared. The reference battery voltage is being compared with this reference voltage, and this has been further allowed to pass with PI controller, and it further generates the reference current, and that reference current is being compared with this line current here, and again the output is being compared is passed to PI controller. Again, you get the tuning of this both all the PI controller which I've used is being done with the help of all the hidden trial bases here. Okay, now after certain this equalizer here, this and SR flip flop, this PWM switching pulses has been generated. In the stage 3, if you can see again, the battery current has been compared with the battery, which is battery current has been compared with this reference value, and this the error has been passed to PI controller, and it has been further been passed on to PWM generator, and it provides another set of switching pulses. So here you can see we have 6 switching pulses for the 6-part transistor converter. This further operated is DC converter here. Now, although we have used this solar photovoltaic cell here, so this is the modeling of the solar photovoltaic cell. So here you can see like this photovoltaic current is being measured with the help of this. These are the few standards formula like for photovoltaic cells and which is being IPV is equal to IPH minus I naught. Yes, standard formula. I naught is the reverse saturation current here. IPV is this one here. Okay, these are the modeling aspect. Now, our research allow how we can minimize the battery size, battery price. Okay, so that has been done by considering an objective function. So my objective function is like considering of 4 parameters: battery size, number of batteries I have taken, battery price, and the last one is SOC. Normally, SOC is what the remaining capacity by total capacity. Okay, so but here I consider in terms of the power generated from the solar minus the difference between the power generated from the solar and power delivered to the load. Thereafter, this objective function can be more elaborated like I've taken battery size, that is En minus Qi K1 n square minus Q1 at 80. This objective function I will develop from my side. Further, in terms of K1, K2, K3 charging aspect here, and in terms of number of batteries, basically the number of batteries which I operate in my this hardware system here, they can be arranged in the form of vertical as well as horizontal here. So in that one, this is one aspect. Another one I have taken like 3 variables like K1, K2, K3. So these parameters can be controlled are being trained with the help of genetic algorithm. Now, battery specification is basically in terms of kilowatt hour. So the selection of this available batteries 8 here. So in my case, I have taken total 8 batteries. So it is up to us whether I can take the configuration like 4x4, 4x2, with 4 battery in vertical, 4 battery horizontal, and either 6 like 4 aspects here. So as I told you that our parameter K1, K2, K3, they are being trained with the help of genetic algorithm. So what is genetic algorithm? It is basically the optimization method that allow the mimics of the natural genetics. Okay, so it has 3 major steps: the reproduction, crossover, and mutations. In my case, once the objective functions has been designed in terms of this battery sizing, pricing, configuration, now further it has been trained with the help of this reproduction, crossover, mutation, which are the very basic steps of genetic algorithm. After being trained the multi-objective functions with the GA, another aspect I have considered is the battery cost aspect, that is BPT. Okay, it has been further designed in terms of again our charging aspect, our previous variable like K1, K2, K3. In addition to that, I have also taken the 4 additional parameters, which is called to be a cost factor, which are being measured in terms of dollar per kilowatt hour. So this is the objective function I've developed from my side. So K1, if you can see the cost factor K5 and K6, they are totally dependent upon this battery cost here and this SOC. So I have considered this maximum minimum limit in the in its maximum minimum limit by considering this more iterative from here. So that I can see that what is the most optimal solution here. So after designing this EV, after designing the objective function in terms of battery size, battery price, and the available number of battery and certain variable parameters, and trained with genetic algorithm, so as I told you that I have taken total 8 batteries. So there are what is a small n here is the total configuration. It's like Is it possible like other I can arrange 1 by 8 means I can arrange all the batteries in a column. 8 by 1 means I can arrange the battery in vertical. Sorry, in totally rows. There are other aspects 4 by 2, 4 by 4, 2 by 4. So while considering these various configurations, what I observe, I've got a very this total objective, this total cost, where in the variable form for the various configurations. So it is like 1 by 8 is 13.9, 13.2. So what is our objective? My objective is how, because this is a basically battery size. So we have to check on which configuration I'm getting the least battery size. So I observe with 4 by 4 battery, 4 by 4 certain number of configuration, my battery size has been reduced. It is the most least battery size when I'm operating for 4 by 4 battery size configuration. In order to validate more 4 by 4 configurations, earlier was battery size. Now this is a battery cost. Okay. So this battery cost has been further measured again for same type of various configuration. There is 1 by 8, 8 by 1, 4 by 2, 4 by 4, 2 by 4 here. So again, you can see this battery cost first has been measured with the conventional method. After that, it has been measured with the help of genetic algorithm. So if you can find out more or less once the genetic algorithm has been applied, you can find out battery cost has been reduced in comparison to the conventional method. Again, we have to see with the assistance of this genetic algorithm, which configuration is providing the least cost. So again, here you can see 4 by 4 comes forward and it is provides the most best result in terms of least battery cost here. So this is the again the advantages of this 4 by 4 configuration in terms of both, because it is providing both least battery size and least battery cost in my research here. So as I said, this was the next objective. As I told you, the how we can check the maintenance of this EV battery here. That is measured in terms of the risk factor. Basically, risk factor is basically analyze checking the life expectancy of the battery. And the risk factor is basically what? Minimum desired kVH divided by rated kVH into N. This is a topical formula here. So again, this risk factor has been measured for various configurations which I have taken under the variable loading conditions. So for what I see for 1 by 8, it is 25, 25% is full loading condition. For 8 by 8, it is 40% of the full load condition. For 4 by 2, it is 60%. For 4 by 4, because it is providing the most best result. So I've taken like a very heavy load for this one. For 2 by 4, I've taken the full load here. So again, it is found that the 4 by 4 is providing the least risk factor. It means least risk factor means the better possibility of surviving the battery for the longer duration. Okay, so this is like the risk factor is the least with the genetic algorithm is compared to the conventional one, and 4 by 4 configuration is providing the least risk factor in comparison to the given this configuration here. So this is my hardware, one section of the hardware. So I've arranged my all these 4 battery, 4 in vertical, 4 in horizontal here. Accordingly, I'm getting this best result with this such configuration. Now again, if we see the modeling aspect of the EV, so these are the few standard equations of the EV. Like I've taken into C1, R2, VVC. So these are the modeling equations which I have did from my side. Okay, again, this VVD is called battery voltage, QL is called charging aspect, Q loss is called again this power loss here. Okay. After that, SOC has been measured in terms of this. D is called my duty cycle here. Okay. So this is I been considered like K D upon D max. And further, I have measured the SOC for both charging as well as discharging. So for charging SOC, it is like first I have taken this initial value, which is further taken in addition to like DT past and previous value of the charging here. Same for the charging aspect. I've taken the charging for the previous and the present value here. It's like a causal system here. Okay. Now what happens if I have to check the power from the EV to grid? I find out like it can be taken like the total charging power SOC minus the charging power. Same thing from grid to EV. It can be measured like the charging power SOC minus charging SOC here. Again, it is like the various steps for this charging here. I modeling of this EV has been done. Further, the SOC of the so both charging and discharging has been estimated. Further, I have estimated the total power handling capacity of the grid. total absorption of regenerative braking from the EV to grid air, total traveling time, everything is being checked. Because normally this was if the same approach will apply for any vendor, so we have to check total travel time, total waiting time, if any vendor is connected, is there to supply the battery here. Thereafter, since it is a grid, if it is a grid rated system here, I also measure the voltage across the grid. So this find out like this voltage is approaching to its reference value here. Further, now as I told you that the power has been checked from both grid to vehicle and vehicle to grid. So it is observed that from grid to EV, so the power is in positive. It is around from five. It is in the range of 500 watt air. But when it is revert back from EV to grid, so it is normally the direction of the power will get reversed. So that is why they take it minus 500 watt. So after this implication of my this research, I found out I checked the saving power. So as here the saving power has been increased, and for the various voltage level, here you can see like it works here. Waiting time has also reduced. Time to reach in is also reduced. As the voltage level, what is the beauty of this research here? As the higher the voltage is, minimum the saving power, minimum the waiting time, and minimum time to reach the plug-in. The another designing of this controller is called heuristic lipogenic fuzzy logic controller, which is used for controlling the DC-DC converter controlling here. So what I did here, as here you can see, the charging it has been sensed and compared with its reference value. Once it is being compared, the error has been generated. After generating the error, what happens? The change in error has been done, has been checked. Because automatically we know that for the fuzzy logic controller, we require at least two inputs. So I have taken the one input like error, another again I have taken change in error. So this can also be better understood with the help of this flow chart. So it is like the begin with the design of this non-linear polynomials. After that, this polynomial can be expressed in terms of Lagrange function which has been discussed, which has been displayed here. Thereafter, you can estimate these eigenvalues. Thereafter, you can apply the CPFSO technique, CPSO to compute this LF coefficient, the proposal algorithm. Now, this evaluates CPSO objective function to compute this DA method here. Then we can check its DMA maximum value. Okay. Another way is like a fuzzy logic. Normally, we provide the two type of input in the fuzzy, but in this case, I have taken three inputs: error, change in error, and change in power. With the assistance of these three input, I can provide a certain needed pulse to this DC-DC converter here. So as I told you that I have taken the three inputs: error, change in error, and this change in power. Accordingly, I have taken it like 9 by 9 matrices here. And for each 9 by 9, we have a certain output. NV stands for reactional terms. NV stands for negative big, NM stands for negative medium, PS for positive small. So all these nomenclature are being placed here by considering certain ranges. Normally, you have taken the ranges like NV stands for 0 to 0 to 0.25. NM is like from 0.25 to 0.5. Likewise, for a various ranges, we have taken the various nomenclature. Now we have taken the voltage of the EV with this various radiations level. For 100 lumen radiation, it is found like, and with the assistance of fuzzy, the voltage level is found to be constant, which is found to be somehow better with because without fuzzy, it is not being settled. But with the fuzzy, it is being settled here. Again, with the implementation of fuzzy, the voltage has been settled up to 125 volt here. Now, the variable temperature effect has also been checked. It is like says like the EV voltage, EV terminal charging voltage has been taken for checking this rise in time here. So it is observed like, and this rise in time has been checked without fuzzy and with fuzzy. So with FLC stands for fuzzy logic controller. So for the various voltage level, it is observed that the rise in time is least with FLC as compared to the without FLC. Again, I also implemented this machine learning algorithm for this EV charging here. It is like a dynamic wireless charging scheme for EV here. So in this one, I'm taking like enhanced DSDV controller. So this is the another one here. Okay. So this is another part. Like in this one, what I did in the suppose if the EV is being running on the road, and it is seen that there is a charging aspect, charging of the battery is very limited. It is required to charge the EV from the available charging system. So what I did, so there are certain operations has been provided, like it is based totally within IoT. How the EV can search a nearby charging stations with the support of IoT here. So that is one of the research here. So with the help of IoT, it can be seen that whatever the nearby charging station, it will directly get intimated through certain app or something like that. So it can easily assist the EV to get charged here. Another one experimental based on machine learning implementation, like the power charging of EV, and this is power, how the power can be transmitted with EV, how the power transmitted of the EV here. Okay, how it is more efficient. So in this one, like I've taken that whereas EV like 10 EV, 20, 30, 40 like that. Another one is like regenerative actions. So what I did, the output of the solar is being connected to MPPT, and further MPPT is used for this controlling of DC motor. Another DC motor is further allowed to drive in. Normally, we are using BLDC motor here, but in this my research, it begins with like with the DC motor here, and this DC motor is being allowed to run this EV. And now, because I told you that it is required to regenerative, it is required to implement the regenerative braking action. So that regenerative braking actions uh, can be analyzed, and it regenerates the power back to the source here. So, but regenerative actions has been done with the help of controller. It is called LQR controller. Okay, so it has been the regenerative action has been dealt with without and with LQR controllers. First, we see how LQR can be controlled, can be applied. So here you can see like battery voltage has been compared, change in voltage has been measured, and is further passes through gain G and H. Thereafter, change in speed has been obtained, which is being further compared to the reference value. Now this speed has been passed on to high pass filter. And now thereafter, LQR controller has been applied. You can see in the feedback form, which consists of three parameters main, capital R, B, P, Z. And R, B, Z has a way to find out from its certain derivations, but P can be find out from this denominator, from this lower term, that is A transpose P plus P A minus something like that. Okay. In the this LQR has been modified with the assistance of fuzzy logic controller. Here you can see in the previous diagram we have used the HPF here. Now here I've used the FLC. FLC is called fuzzy logic controller here. So this fuzzy logic controller, what it is, I told you that it required two inputs. So here I've taken change in speed and rate of change in speed. After that, with the implementation of fuzzy logic controller, so this becomes LQR based FLC. So it is expected to get some better results with LQR based FLC. So after applying this one, we find out the torque here. So as here you can see, we are getting a negative torque. Negative torque means it is providing regenerative braking actions. Okay, negative torque means it is regenerating the power. So as here you can see, it is being worked with without LQR, with LQR, and LQR based fuzzy. So as here you can see, the LQR based fuzzy is providing the best result because it has no transient and it is providing the least settling time. Additional advantage can be measured in terms of power saving and efficiency. So we can see LQR by FLC is providing, it is saving a lot of power. It is saving more power. That earlier it was 11.9 for 25 kilowatt per meter square radius, which has been increased to 24. Same for the efficiency. Efficiency has also been increased from 69.8 to 89.4. So further you can see for the other radiations level, the power saving has been increased and efficiency has been also increased here. So this is the future of this EV. Like as here you can see, day by day, the contribution for the society of the EV has been increased. Okay, sale is increasing continuously. More models are coming, and it is expecting that that by 2030, data was it is like at least 25% EV can be sales. But I'm expecting from from this predictions and from this regular utilization by the consumers, it will increase up to 75%. So this is the current research on which this is the current research on EV which I am doing in my laboratory here. So this is like again the charging of EV with the grid here. So here you can see like this EV is getting charged. There are two ways. The first, it is the first one way like EV is getting charged from the grid with the assistance of this grid side converter here and DC-DC converter here. Okay, so what happens? This MCB has been provided for this for this circuit breaker. MCB is like a miniature circuit breaker. Once it is being closed, the power is being delivered from grid to grid side converter with the help of the LCL filter. LCL filter basically are removing the harmonics in the grid. Further, the grid side converter are there, and the output of the grid side converter is further driving the DC-DC converter. Now the DC-DC converter output is being for charging this EV with the inductor and MCB. This is how EV can be charged here. So here you can see that my grid capacity is 415 volt, and my this EV is 100 Ah 72 volt. Another mode is possible because once the EVs get fully charged, if I open this MCB, what happens? There's a way because there's a one more feedback provide has been connected. So this is the one way, this is the way of charging, and the charging has been done to another way. Okay, and this is being assessed with the help of my this BCD controller and PC controller here. Okay, so this is another way like the grid side converter is getting power from this charging battery, and it is further read back to this grid here. These are the various parameters of for my charging, discharging of the battery. I'm taking like power times configuration like rectifier, braking chopper, inverters, rectifier of 4415 volt AC, inverter 560 volt here. Chopper rating is 600 volt, input 305 volt, inverter is 600 volt link. Switching frequency I've taken up 20 kilohertz, fundamental frequency 50 hertz, holding air capacity. Power converter consists of this various module like 1 by SKD, 160 by 18 module, and like that. So these are the few glimpses of my research in my laboratory. Like as I told you that this is a way to get EV charge. And but thing is how this grid side converter and DC-DC converter is getting switching pulses. So this grid side converter is getting switching pulses from this vector controlled method here. This is the real interface system here. The model has been developed on the system. After that, it has been interfaced with the of this FPGA controller. And these are the few results like you can see like how this will be this will be DC link getting a power around 630 volt here, as there you can see. Okay, so this is my current research, and this is still going on. So these are the certain outcomes of my study. Few research paper published on IEEE Transitional Sustainable Computing and this IT Journal Research, and 4 patent has been published based on this research here. So this is from my site. Thank you so much. So any questions from the participants? Most welcome, sir.
Thank you very much, sir, for this very important and interesting topic which we have learned today. RSL Ahmedabad and Atulji, can you please make the participants the panelists so that we can take the photographs?
Yes, sir.
Dr. Saab, kindly unshare your PPT, please, and share me on my WhatsApp so that I can put it on our website.
Sure, sure, sir.
Thank you. Atulji, can you take the photographs?
Should I stop this sharing?
Yeah, please. With this, I would like to thank all the participants, our expert today, Professor Dr. Abhinav Saxena Saab. We will meet next week with the next topic. Thank you. Thank you very much.